This talk is on what I call digital archaeology, decrypting, disassembling, and decompiling a 44-year-old killer app for the Mattel Aquarius. I want to provide a little bit of a history for Aquarius, because I always do, because I'm like one of 3 Aquarius nerds here at the show. And then also talk about Treasure of Tarmin and how it was developed. Then I'll go into the processes and tools I used for decrypting the cartridge, disassembling it, decompiling it to a degree, and then doing some enhancements for it. I work for Ventura County Fire Department. I have a development team of 5 who do everything from iOS development for the mobile apps that we deploy to the field. We also bring in, off-the-shelf tools, software as a service tools like Chronos time management for the firefighters to put in their time. For a while I was teaching at California Lutheran University, but the educational space, as Mr. Haas can tell you, is in a massive change, tide change. So I'm giving that a little bit of a pause for my sanity. And I'm also part of the Aquarius Plus development team, which developed a modern version of the Aquarius a couple of years ago. I took a long time to get my degree. It took me almost half of my life. I started out junior college. I came out to California from Midwest to Cal Arts. I met my wife there, so I did get something out of it, if not a degree. I eventually got my bachelor's and master's in computer science at Cal Lutheran, which prompted me to stick around and do some teaching there. There I taught software engineering, a little bit of AI, not much you can do in an introductory class with AI because it's such a deep subject. Most of the time I taught data structures and algorithms to people who did not want to learn data structures and algorithms and the importance, and a lot of project management, particularly for PMP and CAPM certification for people who wanted to get those. Although there's not much of that going around anymore. We do smaller projects. Again, I've dealt with the Aquarius Plus, worked with Perifractic and some others on some C64 projects like the VIC-2 board. And then I've done a lot of Aquarius upgrades. I've reverse engineered the motherboard, the case, created a couple of expansion modules and some AV options for those. So why Treasure of Tarmin? Why this D&D game? Well, this is the 1984 version of me, 17-year-old nerd. It was my first game. For any of you who've ever gotten that first console, that first computer, it was the first time when you had no time limit. You could stay up till 2, 3 in the morning playing if you wanted to, as long as it wasn't a school night. And you could leave it on if you wanted to. And that was important on this game because there was no save feature. You all remember that, whether it was your first console or whatever. For the more modern generation, your first phone, when you're 12 or 13. Huge D&D fan, always have been. And it was interesting because it was kind of the first time I had dealt with the first person immersive view. It wasn't real time, it wasn't rendered or anything special like that, but there were a couple of other text-based games that you could play that were kind of first person-ish, but this was the first time I'd actually seen it in a cartridge. And it just worked. The great thing about console-based systems, including the Aquarius, which is both a console and a computer, is that it just works. You turn it off and it's off. You plug it in, it just works. But what about the 40-year-old version of me? Protection through the Aquarius Plus project. I've had a couple of scares. The cartridge that we're dealing with today has a significant IP overhead. Even though once you get in the game, you couldn't tell that it's a D&D product. It was originally owned by TSR Hobbies. TSR got absorbed by Wizards of the Coast, the Magic Gathering card guys, and then now it's owned by Hasbro, and it's a very active property for them. So the last thing they want is to hear, oh, somebody's copying D&D games out there. Well, it's on the title screen and that's about it. So I would like to be able to release the ROMs for the Aquarius, which nobody cares about, and at least make them playable by people who want to be able to play the game, but just kind of take that IP off. Yeah.
Yeah, earlier on your slide you mentioned something about where I thought I heard you say something like it's like a D&D-like experience, but it sounds like it's part of that D&D world, that IP. It's actually a D&D sort of...
It was. Yeah, and we'll talk about how Tom Loughry developed it. He developed it as a game called Minotaur. There was no intent to overlay the D&D thing, but Mattel said, well, you hear about this new thing, let's brand it to sell it more. Obviously, there's a lot of Tron cartridges within both the Intellivision and the Aquarius world. Tron's a very hot property. They've got a new movie coming out. Disney may or may not have heard. They're a little litigious at times. So I wanted to protect the product, but I also wanted to be able to distribute cartridges, the original ROM files with it. I also wanted to play with some new tools. Ghidra, which I'll talk about, is a great decompiling tool, a disassembly and decompiling tool. The Aquarius Plus emulator I use. I wanted to learn Z80 assembly language. I came up through scripted-based languages. Started off in HyperCard on the Mac. Of course, it transitioned into some other things, but I've dealt with a lot of interpreted languages, JavaScript, all of those sorts of things. And I only recently kind of got into, within the past 12 years, got into compiled languages. So I wanted to learn more about Z80 assembly because some of the people who I work with use a lot of Z80 assembly language, and I kind of wanted to get myself up to par on those. I also like to be able to demonstrate the Aquarius Plus platform a little bit more and what it can do. So here's the tragic tale of the Aquarius in 5 minutes or less. It was developed by Radifin, who was the main manufacturer for Mattel Electronics. They manufactured most of the Intellivisions that were out there, but they also developed the Aquarius and presented it to Mattel, and Mattel said, hey, this might get the FCC off our backs about the, not having a computer thing. Didn't really work out that way. It was released on June 5th in 1983 at the CES in Chicago, and then it was canceled 6 months later in 1983 because that was the overall market crash that happened late 83, 84. I've spoken to Laurie Scott, who was the president of Radifin, and he was going to visit Mattel Electronics down in El Segundo, and he tells a story of an engineer who happened to be paraplegic with his box of stuff kind of being pushed out these flapping doors at Mattel Electronics, and he's like, it was pretty grim. So what happened was Mattel said, we're going to get out of the electronics business. We'll focus on Barbie and Hot Wheels. Radifin, as part of the contract, you take the intellectual property for the Aquarius. And they did. They sold it for probably another 6 years or so. If your parents, or maybe some of you, ever went to a presentation when you're hearing about a property, a timeshare property, and you get a free computer, it was probably an Aquarius. But then Radifin themselves closed in 91. The people who bought their assets really just wanted the real estate within Hong Kong. They didn't really care about this IP. So the Aquarius is, for all intents and purposes, an open source kind of abandoned hardware project. That's why we love it so much. Here's some of the specifications on it. Nothing particularly great. There were some upgrades. You can get an expander. If you take a look at Salam's booth upstairs, we've got a couple of these items. And there was an Aquarius 2 that actually had a real mechanical keyboard. This was the main problem with it. This type of computer had been out since the late 70s. The TI-99 was basically the Speccy, either the 80, 81, or the Speccy were pretty much these same, specs. So let's talk about Treasure of Tarmin. It was developed by Tom Loughry. He at that time was working for APH Technologies, which was out of Pasadena, 81, 82 timeframe. He developed it as a game called Minotaur. Again, there was no intent to have this TSR branding on it, but Mattel saw an opportunity. We've done some research. If any of you know the Strong Museum of Play in Rochester, New York, Tom Loughry, about a year and a half ago, donated all of his papers to the museum. So a friend of mine who lives in Rochester was able to go in and take a look at his notes. It only runs in 2K of RAM because if you're plugging in the cartridge, you want to make sure that you have enough memory to do it. And the stock Aquarius really only has 2K of built-in available RAM, not including video RAM. And it used entirely ASCII, or what we call Aquascii graphics. Like the Commodores, they have their own special character set. You've got some of these fun characters that you can use, and it's surprisingly effective, particularly when you use forward and backwards graphics on what you can achieve in these. So here, as an example in the game, here's a picture of a bat, and if you look at his ears, you can see that those are the little airplanes over there. It's pretty clever. Here's a picture of the dragon, I guess. I don't want to crap on what Tom Loughry did, but that does not look like a dragon to me. But again, he did this in about 60 days. So, and he was doing this on a PDP-11. So kudos to him. I've got a CPU that's a million times faster than that. Within the package, it had this. It had the cartridge itself, which is the classic wedge shape for the Aquarius cartridges. It had a keyboard overlay, which has some of the commands on it. And it has a hand controller overlay for the 6 buttons that are on the hand controller that tell you the different things. There's also kind of a shift key that allows you to have a total of 10 commands that map roughly to the action commands there. So when you're dealing with ROM files within the Aquarius, they're almost always saved as 16K ROMs. But it only has 12K. It's got a 4K ROM and an 8K ROM, so you really only have 12K in this. Those are expensive back in those days. This chip on the bottom was probably at least twice as expensive, not just because of space, but because there was more to manufacture than the upper one was. And Mattel was already pretty restrictive on how much of these ROMs they would put in cartridges to make it effective. But they knew that this was like I said, a killer app. This is what would sell the Aquarius if they saw that D&D title. All right, a little bit about Tom Loughry. Again, he designed Minotaur for Intellivision. All of the sources we find when he's talking on podcasts or whatever, he primarily covers the Intellivision, which is fine. He later founded a company called Cheshire Engineering where he did more Atari stuff. He worked for Activision, subcontracted, I should say, for Activision. And he was active up until the mid-90s. He did some PlayStation stuff. Unfortunately, he developed some health issues that made it difficult for him to see the screen and type stuff. So he stopped coding in the late 90s. Again, about a year ago, he donated his personal collection to the Museum of Play, and we had access to those. But if you've ever gone to a research museum or a research library, you can't take your own pictures. You have to use their camera. They filter through it. They watermark it to make sure you're not trying to sell it yourself. So there is a bit more of a turnaround time than we expected. So we couldn't find anything specifically in that collection that said, yes, I, Tom Loughry, created the Aquarius version, not that he would admit that in public anyway. But in the code, we do have a couple of bits of binary that say it was programmed by T-Loff, which he used a lot of the time as kind of his alter ego within space. It's also a few characters less than what it was. So it's definitely in there. I doubt another programmer who would have taken it from the Intellivision code to the Aquarius code would have left those Easter eggs in there. It's just, they would have put their own in. So again, 83, late 83, Aquarius died. That's it. Draw the curtains on that. Let's talk about decryption. So the Aquarius uses XOR copy protection, which is a very basic level copy protection. It's cool because it's 2 ways. It's easy, it's fast, it's maintained in hardware. The Aquarius has a chip called the PLA. What happens at boot up is you take the bytes in the cartridge that are from E1000 up to EOOF, which is 16 bytes, takes those, calculates a 1 byte scramble code, and it sends it out the FFIO port, which is where the keyboard is. Keyboards are obviously inbound things, but this one thing will store that code in there, lock it into the PLA, and it'll do on-the-fly translation between the external data bus, where the cartridges are, and the internal. Not particularly effective. This was actually figured out way before me. And the way they did it was in this way. They knew that on every splash screen for the Aquarius, it always had this up here, and it had this ASCII string. Now, you didn't know where on the cartridge that was going to be, but you knew where in video RAM it was going to be. So we knew there was an OM twice within about 3 bytes of each other, and then we knew that there was an E at the end of it. That's a pretty easy pattern match. And since XOR is effectively a substitution code, it's basically a decoder ring type of a code, it's easy to find that. So that's exactly what was done. So here's how that works. We found out that this address for the H started at C7F4. So here's how it works. The top line is the encrypted values that were on the cartridge. The bottom line is the decrypted values. So if we take a look at O, if we do O5 XOR with the decrypted, because that's the cool thing about XO, you can take the end state with what you know is the starting state, and then you get the unlock key. So it's a 3-way key, kind of, for the lack of a better term. So when you do this, you get 4A. Well, now let's test that in reverse on the M, the 07. If you 07 XOR 4A, you get the 4D, which again is on the bottom line. So that's easy. That was easy to figure out. Again, they figured it out a long time ago. There's Python scripts that'll do that pretty easily. So we had a disassembled, or we had a decrypted version. Now let's disassemble it. There are a couple of tools that you can use for that. The first one I used was a tool called SchoolKit. Now SchoolKit is particularly for the speckies. It was originally used to decrypt a game called School Days, which is why it's called SchoolKit. It can take tape images and other things, and its whole purpose is to create HTML files for the purposes of documenting each of the points in RAM. It's very cool. It uses Python to process it. You're basically running in a Visual Studio project. And it will output ASM file, a list file, and of course binary files. Super useful. So I had some successes with it. I was able to identify where that duplicate 4K was and what it was. It was basically a copy of the lower 4K because the logic chip that was used is basically turning it on both times. So it's putting it back out. It doesn't check. It says, oh, I'm gonna respond to both the C1000 range and the D1000 range. I was also able to find the section that was graphic pointers. SchoolKit's very good about kind of creating linkages between 2-byte words, and where they can check in the rest of memory. And it noticed that within the space that I was doing, it had a big table that happened to map to other sections of code. So I was able to find the pointer table. I was able to identify the draw graphics function that Tom Loughry had created, and it's kind of clever. We'll talk about that in a second. And I was still able to take the ROM out, do a little bit of patching. I was able to take the TSR hobbies off, the Advanced Dungeons and Dragons off, and I think I called it at the time Deep Dark Dungeon Adventure, something like that. So I still had the dnd.rom that people were used to, but it didn't have any of what was left of the TSR, now Hasbro IP on it. But it wasn't perfect. Some of the misses. HTML's cool, but I didn't have a need for it. And that's kind of an overhead part of it. It's very tedious to scroll through the HTML to find what I wanted to. It's much more useful for me to see it in state. Patching the code was super tedious. SchoolKit uses a control file, and you have to manually overwrite that, and it's very, very tedious. And again, it's geared towards Spectrum disassembly. It's not used to dealing with kind of these routines that are in this Aquarius ASCII graphics. So the tool that I wound up and that I've done most of my work in is a tool called Ghidra, named after the famous monster that is sometimes a friend, sometimes a foe of Godzilla. It is designed by the NSA, National Security Agency, that agency, for the purposes of reverse engineering embedded code in devices that come in from out of the country. Make sure that that webcam that you're looking at isn't doing a bunch of stuff, or it doesn't have stupid, anonymous 1, 2, 3, 4, 5, 6, 7, 8 passwords in it. And it supports about 16 families of processors. It's super cool. It disassembles. It's great at auto-identifying and doing updates for labels, markers in real time. You can very easily override and rewrite sections of code, and you can do this either by direct editing of the ROM or of the binary code, or you can add overlay space that then can be swapped in for that chunk of RAM later on. So it's very flexible. It will decompile to C, but in terms of the successes, which we'll show in a second, that's not an exact science. And it's great at exporting the binary files for testing very quickly. So my successes, I finished mapping all the graphic files and all the pointers, naming what each of them were. I was able to document most functions to a degree, not all of them. I was able to map all of the game variables. I added a new 2K startup screen that looks much better than the one you saw. And I was able to start to add some new graphics. That dragon that I love so much, it looks more like a dragon now. But mainly I was able to add some cheat codes in there. Not perfect, very manual relocation of code. I just went through a whole refactoring. That spare 2K that I had at the D1000 space, the new title screens at the top of that, I had about 2K of space that I can start to create the graphics, but I had to wipe that and put that. So I did a refactoring the past couple days to move those in. It's a very, very manual process. There's a lot to learn. It's written in Java, so it's very extensible. If you have a new processor you want to add to it, it's pretty easy. Great community, a lot of really good videos on how to use it. And again, C decompilation to C code is very abstract. A Z80 register is not a variable. It's a pathway to get stuff in and out of values and variables, but they aren't themselves. And this product tends to want to pin, let's say, the DE register to this particular variable. Okay, that's great, but it's certainly not universal. That variable does pass through DE, but it doesn't universally throughout the code. All right, another tool, of course, the Aquarius Plus emulator. There have been a couple of really good Aquarius emulators out there. the Aquarius Plus, even though I'm not using any of the Aquarius Plus functions like sprites or programmable character graphics, it has great debugging. It's got traces, it's got breakpoints. I can actually load in an LST file, a list file. So rather than looking for C788, it'll actually show me the label for it, which is pretty cool. And I don't spend an hour writing that down or scratching it in my programmer's calculator. So that's one of the tools. And I can boot directly into cartridge, which is great. If you've ever worked on an Aquarius, you have this annoying return screen at the beginning. You have to hit the return key. Well, with the Aquarius Plus, we've done away where you don't have to deal with that. It'll just boot straight into the ROM, which is nice, as the hardware itself would do. A lot of use of Python, of course, Visual Studio. Aquarius Draw, which is a tool it's a web-based tool that uses the Aquasky graphics. I use a lot of Beyond Compare. If you've never used that tool, fantastic tool for doing comparison files. It's got breakouts for graphics and other things. It's one of the biggest tools in my toolkit, and of course the old binary viewer tool. So let's talk about decompiling. Here's the Aquarius memory map. There are 4 banks of memory. Since we're dealing with the stock Aquarius, we don't have these 2 middle banks. We're not using the middle 32K. So let's get rid of those. Let's expand it. We're going to focus on the hard space, the low-end 16K for the Aquarius. So it breaks out into these sections. The low part of the Aquarius is the core ROM. It's 8K. Then in some versions of the Aquarius 2, there is an extended basic for a total of a 12K ROM. The original Aquarius doesn't have that, so this is just blank space that I can't use for anything. Then you've got 4K. 2K of it is the character RAM, where the actual ASCII values are stored. And then above that is kind of a typical two nibble foreground, background, paper and ink, if you're a specky person, for the color RAM that corresponds exactly 400-ish addresses later. These are not writable, so let's break this out a little bit. The color RAM and character RAM, the Aquarius only has 25 rows. It has a full 40 columns like a lot of computers from that era, but it doesn't have that 26th row. So that means at the end of each chunk of both the character RAM and the screen RAM, or the color RAM, you get an additional 24 bytes. Well, Tom used that for some buffer spaces for how he would plan where the walls go in the cartridge, or in the cartridge development and the mapping space. Within the available 2K of RAM, and you get the full 2K when you're using assembly, because you don't have the basic interpreter pointers and variable pointers and stuff like that. The lowest 256 bytes is the 16 by 16 grid for the map space, pretty cool. Then you have what is called the active item space. And while it does take up 256K, it's not a 16 by 16 grid the same way. It actually has a different starting point. Then there's a buffer that he uses for taking an item through the graphics routine when you're picking something up off the ground and then putting it into your inventory, what I call the graphics buffer space. All the player variables are kind of in the middle 128K. There's a big chunk of unused 64K, and then there's an alternate item space, which seems to be an exact duplicate of the active item space. But I think he uses it as a calculation point for what was in this when I originally, coded this and I originally generated this level. Still don't know exactly what it is. Good news is there's still 1K. That's tons of room for adding some additional variables or buffer space if I wanted to. So let's go back to the memory map. Here's the upper 16K, the cartridge ROM space. On the Aquarius, it goes from C1000 to the top quad F. Here are the page files within that. The Aquarius cartridges actually start at E1000. So if you have a 4K cartridge, you're just using this slice. If it's an 8K, it moves up into the higher level and you now have an 8K cartridge. When you go to a 12 or a 16K, it wraps back around to C1000 and then up into the D1000 range. Now, as I said, this D1000 range isn't used. It's just a complete copy of the C1000 space. Next, I got into mapping out the functions, processing input, generating the maps, placing the ladder. Now, the ladder is the exit to the level. it's important because as you go further down, the calculation of how your health and the maximum health and all these other things are generated, and your success against opponents. There's a routine for drawing graphics, for redrawing the viewport, and that includes a calculation phase and then actual rendering, for the lack of a better term, phase. How do you rest or receive damage, which deals with the health? How do you pick up or use an item? And then how do you draw the title screen? So adding on to these, if I wanted to add any cheats to better test my new graphics and my new functions, I needed to be able to add some new commands in there. He had only mapped out those 10 or 11 or so commands for actions and movement. I needed some more things. So I had to fix that. I wanted to be able to add new items, new monsters to the map. I wanted to be able to teleport to the ladder if I wanted to get further down in the game without just bit banging the level value. I want to create some new graphics. I want to change the color and tone of the game because you're subterranean and you've got this bright cyan sky, and I know we're dealing with, you know, crappy 16 color systems. It is what it is, but there are other colors in the stock palette that would be just fine. So I wanted to change the blue sky, which is supposed to be a ceiling, and kind of a less blue ground to be something that was dark and a little scarier, a little more fun and more adventuresome to deal with. Want to be able to increase health, ammo, and the food that increases the health. Track some of the things that aren't really tracked in the main game. And then, of course, create a new title screen. So there's two paths of input. There's the keyboard, which I said before is IO address FF. It's matrixed. It is a 6x8 matrix that allows you 48 different keys to be pressed. For those of you who haven't done any coding on those sorts of things, you have to create a buffer, check each of the columns, and then check each of the rows within that and store if there are any bytes in that, process that, get rid of any debounce, and that's how you manage that. It's the same whether it's on the keyboard or whether it's in the hand controller. Although the keyboard has 49 keys, it really only has 48 because the reset key, which is in the upper left-hand corner, is just hardwired to the reset in the ground. It's nothing fancy. But the hand controllers only have 6 buttons, so you do have to have a shift function to make full use of what buttons you do have to do the full set of commands. So again, here's those overlays we looked at. The 1, 2, 3, and 4 keys are just for selecting levels. Now what's frustrating about this is you would assume 1 is the easiest, 4 is the hardest. Nope, 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 not so easy. 3 is the easiest, 2 is medium, 1 is hardest, and then 4 is the kind of insane level. Doesn't really tell you that on the title screen, so if you read the manual, it's great, but you know, I don't know if anybody in this room, well, most of us may have read a manual, but it was for other reasons. Playing a game, you got to pick up and play. That's to the plug and play. For the rest of the commands, it's broken into 2 groups, actions on the left, movement on the right. Here are those keys. The Aquarius controller is not like your Atari controller. Up left is not the bits up and left at the same time. It actually has 16 values, and the only way you can do that without taking up all the bits is by making it discrete byte values for each of these. It would be great if, you know, if it would go in some sort of order, but it just absolutely doesn't. You just kind of have to know these. And again, like a keyboard, you have to take them in, debounce them, buffer them. So the disk generally relates to the items on the right. The keypad generally relates to the items on the left, the actions. So the first big function, generating the map, the walls part of it. The wall map, as I said, is a 16 by 16 grid, a byte for each one. It starts at 3,800. Maps wrap around top to bottom and left to right. The Intellivision version has what they call the outer diamond hallway, if you've ever played it. You can't go beyond that. It's like, it's a safe place, there's no monsters there. A lot of people will drop their stuff before they go into a big battle so they can pick it up afterwards and they want to restart. The Aquarius version didn't have that. And it's interesting because he could have easily done that. He had, I think that it was a 6K cartridge, or maybe at the most an 8K cartridge. He had another 4K. He could have easily done that within this space, but it's different animals. Walls and doors are only generated on the north side of a tile and the west side of a tile. So you've got a kind of a L-shaped thing. If you want to get this wall over here, you have to go 1 byte greater to get its west wall value. And it's broken into nibbles. He does have some routines that make sure that there is always an entrance to every tile on the floor, which is pretty cool. He does that through a combination of standard patterns that he lays out and just kind of randomly starts where they're at, and then he tiles the rest of them around that. But he still has a routine that does this thing to make sure every item that might get placed in a particular tile is accessible. Sometimes it may be in a box that has 4 hidden doors on it, and you just got to hit all sides of it. On the wraparound, I don't know if this was because he kept it this way on purpose or not, but if you go north and south and you wrap around from the top of the map down to the south side, it stays in the same column. But if you're wrapping around from far east back around to west, it goes down 1 level. So that's a trick that a lot of people use to just wipe the whole board and pass through everything. It was pretty easy. You know, he could have added, what, 3 or 4 operands in there to -1 when you go on that side. When you wrap around west to east, of course, it minuses 1. So I don't know why I chose to do that, but it's kind of a fun way to play it. So let's take a look at these bits for the wall. It really only uses 3 bits. Bit 7 tells whether or not there is an open door. So that doesn't change until a player interacts with it. It tells if there's a wall there, and then it says if the door is hidden. It doesn't say if there's a door in it, it just says if there's a hidden door. And it's interesting the way he works through it. So this is in the upper nibble. A wall can generate, an upper wall can generate with any of these. You can't get these values until you actually open a door to change that open door bit at the end. Similarly, and kind of in a mirror, the lower nibble, which is for the west wall, doesn't use bit 3, but it's kind of the same. You can only get these on a generated map. You can only get these values after you've interacted with it. So let's take a look at our walls. So if you have a 0, 0, that means you've got no north wall and no west wall. Next, you could have a 2.0, which is a north wall only, a 4.0, which is a north wall with a visible door, a north wall with an invisible door. It'll still act upon it if you do open door, it's just you can't see it because it's the same color as the wall itself. And then the 2 user interaction ones, an open visible door and an open invisible door. You can turn this on the side and you get a total of 36 values for the types of bytes you can have for a map in a particular, or a map tile in a particular section. Again, with these being the only ones that you get when a map level starts up. The rest have to be done through interaction with the user. Then you have what I'll call the item map. And I said there's 2 of them. There's the active and then there's like a copy of it. It doesn't map an item to, it's not the same grid as the 16 by 16. So the first byte in this item map isn't the upper left-hand corner of the map. It's actually a byte that says where within that, what's the offset of the ladder, the exit for the thing. It's then followed by 42, which is the byte for the ladder item. And then it generates the rest of the items in order using an algorithm to say, okay, I know I need this number of food items in here, I need this number of monsters, and it's all based on level, the player's level, the floor level, all of that stuff. Again, I don't exactly know what this alt version of it is, but I do see that it's being checked in some of the functions that I haven't had a chance to map yet. Here are the items. There are some weird items. You know, you've got shields, ring helmets, all the things you would expect in an adventure game. This game is weird because you don't have any melee weapons. You don't have a sword. You've got things that you can throw or shoot. There's really only 4 weapons in this. Arrows, or so I should say bows with arrows. Crossbows also use arrows. And then you've got an axe and a mace, both of which are thrown and then are gone. It would be nice if it would fall at your feet and you can at least pick it up and have the inconvenience of having to do that, or if it would stick in the head of the monster and after you kill him you can pick him up. But part of the inventory management of this game is having enough of those spare things so you can do that. So it's a little tedious. There's also some special things. You see right magic, left magic. Those are the items that are used in the animation where your player's right hand, which is what he does all of his attacking from, flies to the monster on the viewport, and then vice versa. So there's some special things in there. Then we've got monsters. There's only 10 of them. These are the original 10 monsters. The king dragon is what you want to beat. On the easiest level, he starts showing up at level 3, and every level thereafter. Once you beat him, the game is over. Or once you die, the game is over too, and that's more common. And you notice that both items and monsters are each 3 values apart. There's 3 values between dragon and bat. There are 3 values between bows and helmets and stuff like that. The low 2 bits on all items and monsters are the level. Red is the lowest level, yellow is next best, magenta, and then white. And to make it completely insane, it's completely different from the level that you select in the game, so the colors don't match up. I'm trying to deal with that in the documentation that I'm creating. There's a couple of special cases. As I said before, the ladder is 42. The Dragon King is always 9F. It always shows up as a white maximum value monster. There are some things. There's a map that you can use to kind of see what the layout is. There's different versions of it. There is a white map, which is the highest level map, but it doesn't produce a map. It kind of half-assed does the teleport function that the Intellivision version, but it doesn't work very well. Sometimes you'll go randomly one direction to the other. I don't know what he was thinking on that. So how do we draw graphics? So a graphic chunk is a block of a Quasky graphics that's double F terminated. Pretty easy, pretty standard. The pointers are all near the end of the ROM cartridge. Anything less than or equal to 77 is an item. Everything above is a monster, so that's how it tells whether or not you're fighting it or picking it up. There are 6 control characters, not including FF. 0 is an empty character. You can either use 00 or you can use 20, which is the space character. It winds up doing the same thing. You have a return character, which goes down to the next line, so it's a line feed, and it goes back to the index point, which we'll demonstrate in a second. You've got a backspace character, a line feed, which doesn't go back to the index, a 04, which goes up 1 layer, and they kind of use that for positioning when you start to draw, which we'll see. Then there's the AO, which is a reverse color. That's 127, which can also be a space character in the Aquarius, but it allows you to use the full character set, effectively 512 characters, because you have both positive and negative versions. And of course, FF is the end of the graphic. So here's an example of my favorite dragon. This is what it looks like in situ. Let's get rid of the walls. Here's the code for that, and I've highlighted the control characters. So if we want to draw this, we have to start at an index point, which is here. It's about the middle bottom of the wall that's right in front of you. So we got 4 characters, which is up. So we go up 5 times to kind of position our graphic up, because remember, it's a top-down type of a rendering thing. Then we want to back up 1, which is the yellow character. And this is going to be hard to see, but the first character is a little thin line, which is right here on that. You may or may not be able to see it. Let's remove the characters, the color characters, and you kind of see it here. And this is all that is on this line. So the next you have is the 01, returns down to the index level, which is not here where it is. It's here where we started. We went up this way. And we're going to draw the next line. That's those characters 97, B9, E6. And we just progress down the screen as we draw these graphics. I knew it was a mistake to add builds to these. The fine art of PowerPoint. Here we go. So here's the finished graphics. And again, it's using this clever little airplanes as its feet. It's kind of cute. But again, I can't really tell what this is. Oh, I forgot the tail, the last piece. So here it is back in its normal state. I'm doing that. There we go. So that's how you draw a dragon. Now this one doesn't have any 03 control characters in it. It doesn't have any reverse characters in it. I don't know why he didn't do that. I think it could have looked a lot better if he had. He tends to not use reverse characters within items that you pick up, and I'll show you some anomalies with that. So redrawing the view part. There's 2 parts. You calculate based on what your position is, and then you redraw it. You've got to render walls, doors, items, and monsters. So first you have to determine where you are in this 16 by 16 grid. We've got a couple of walls, what I call forward 0, left 0, and right 0. That's your cell that you're in. Ahead of you, you have forward 1, left 1, right 1, and then the 2 walls that are parallel to the one in front of you, front left 0, front right 0. And there's about 19 of these items that I have mapped out that each get redrawn in a different way. So let's say we're facing north, okay? And let's say we're right in the middle of the grid. We've got nothing in front of us, so it's a 0, 0. Let's do a wall set with 22, 22, wall to the north in front of us, wall to the left, to the west of us. Here it is. Now we now have 22 in that value. to the right of us, 1 byte ahead, is going to be the 2 bytes. You can see both the right wall, or the west wall, and the north wall, because again, we're facing north. We want to go to this side. Now, we don't have the west wall. We can't see it. It's off camera, so we only have to deal with that upper nibble. Let's go 1 step ahead. Similar to this one, we don't have a lower nibble on this because we can't see the west wall. In front of us, we can see both. Diagonally front to the right of us, we can also see both, so we have to determine whether we render those. Behind that, we can see those. Then everything else, except for the one to the right side of this, you only render the back wall. It does no other perpendicular walls beyond what is your corridor ahead of you. Again, with the exception of this guy here, where you can see both the west wall and the north wall. So that's great. So what does the view look like within the space? This kind of approximates what your view is. Okay, well, what if we're looking south? Well, let's see what that does. Let's spin that around. Here's that set of bytes. You still have 19 nibbles that you're dealing with, but now you're across 15 bytes, which is more operands that you have to go through. Let's take a look west. Here's those byte values. East. Here's those values. This is great. What if you're at the edge? Okay, now it gets tricky. Remember, we've got the weird wraparound east to west. So we take each of these components, and we'll notice the ones on the left side are down 1 layer because of the offset by 1. And then we kind of scrunch these in. We're still dealing with the same 19 nibbles across 15 bytes. We just have to be smarter about where the bounds of this 16 by 16 chunk of memory are. Okay, so now let's render it. Now we have to see whether or not a wall is actually there. So if we have one in front of us, if you take a look at F0, if we're drawing F0, there's a whole lot of shit we don't need to draw. Basically everything that is in this area that's covered up by this big square doesn't need to be rendered. So what he developed was a matrix. So let's take a look at the same view. If we have this wall in front of us, F0, this dotted line says that anything in red, I don't even need to bother rendering. So we can save a lot of cycles on that, which is pretty cool. And it works its way down. Now, he went through a weird byte pattern and a bunch of rotate rights and lefts and stuff like that to make this happen. I think this could be easily done in a big chunk and just do check bit, set bit, those sorts of things. I think it would be much easier to do. But he didn't. So again, you don't need to render any of these. Now there are some weird sections. So a couple of the walls, in the back particularly, you have half boundaries. So it actually creates 16 objects, not 19. So if you have this one, you have to render the outside parts of the wall, but not the in ones. Now I suppose if you're doing this, just why make it difficult? Why add extra code to check for that? Just draw them and take the hit, right? But there are some instances where you do need to have just those sections. Similarly, if you're drawing the outside walls, right or left 0 and right 0, you want to draw only the inside ones. He does check for that. Now, items. Items will render only in these 4 spaces. An item can be in the same space with you, so you can pick it up. A slightly smaller version will be here, and then what I call the tiny version will be diagonal from you, or way back 2 cells away. It won't render any of these other spots, which is pretty handy. Items can be generally 4 by 4. Here's an example of the crossbow. They have the small version, which is 2 by 2, and it's really challenging sometimes to get the 2 to look close enough alike so you know what they are. And then the tiny one is generally a 1 by 1. All on this one, it's been cheated a little bit. It's got an upper and a left line, so it's not really a 1 by 1. It doesn't like reverse characters. So the line over here on the right side of the crossbow is actually a reverse character of a big block character. It doesn't behave really well when you try and get it into your inventory. It tries to do a negative of it, and it does some weird stuff. Next is presence of monsters. Now, a monster cannot be in your space, so you don't have to render him in this space. They're always going to be in front of you. If they're to the side, it'll actually do rah, and they'll get first attack, and then they'll be in front of you, so it's the same thing. There's only 2 sizes. There's an 8 by 8. Here's an example of a new griffin that I created for it, for the regular size one. And then here's the one for the smaller one. Again, it's a little challenging to make it look like that. It does make use of the negative characters a little bit, but it handles that part perfectly well. All right, open doors. Now, open doors, if a door is open, I assume you can see as far as you want. He chose to make it a black space that only shows an item immediately behind it. So even though there may be a monster here, that can attack you when you open a door, it's not going to render this little small item or a small monster behind him behind that. It's only going to render the door that's in front of you. The other thing is it doesn't render any of the side doors when they're open. So simplification of how we managed it. Okay, some of the other functions. Let's do some enhancements. So here's the title screen. Again, this is on every cartridge. Here's the branding to let you know it's a dragon. And then here's the intellectual property stuff that I was very quick to get rid of. But what do you do now? Remember, we've got the level select. What does that mean? I don't know. What is it? What do I push? If you push any other key or any other button than the ones that you have, you automatically get the hardest level. So too bad for you. Hit the reset switch. But it only takes up 350 bytes because it's really only doing 3 graphics. Those are super small. You're already using the graphics function to make it do what it needs to do. Here's my title screen. Making much better use of it. Unfortunately, it's 2K. Oof. But at least I tell you what you're doing. I know it's a little hard to see the blue here, but it's got a little picture, kind of a background thing of the Minotaur, and I was able to actually add some animation of the, if you wait long enough, the Minotaur will do his blinking thing. Oh, it's kind of creepy. But I think it was worth it. I think it was worth the space, and this actually looks more like the Aquarius logo. So let's go back to our cartridge. So remember, we've got an additional 4K now that we're going to use. What are we going to do with it? Well, yay! We're going to add a new 2K ROM, and we've got 2K to add some new graphics too. Again, I love Tom Loughry's graphics. He did this thing in about 60 days. You know, everything from design to coding to testing to taking all of his notes, sending them over to Mattel to have them manufacture it. Kudos to him. And he was doing this on a PDP-11, which great for the time. I ain't using that shit today to code my stuff. I'm going to be using an emulator and other things. And I have tools like Aquarius Draw that are better at taking the Aquasky graphics set and doing stuff with them. So here's what Aquarius Draw looks like. You've got all the set of graphics over there. It's much easier to add, and I've got it in what we call bloxel mode. So there's a 2x3 bloxel where you can actually carve out and do chunky pixels on this. I've got a couple of new things. Here's the original book. Here's the bow. So here's their dragon, and then here's my dragon. Looks a little more like a dragon. So, and then here's kind of a new axe, a new spell book, which I make a scroll, and a bow that's actually pointed in the direction that shoots up. Here's a spider. That's cute. You know, it looks like a Western exterminator bug, something you might actually be upset with wanting to kill. So I said, oh, let's actually make it look like a spider. So we did. Now remember, we not only have to make the big 8x8 one, but we also have to make the smaller one. That's kind of difficult. So I had to have weird use of X and Y. I don't like using, real letter graphics, but I didn't have much choice when you want to have a bunch of spindly legs. And here's a few more things that I was experimenting with updating. Now you have boxes that you can pick up, locked and non-locked boxes. I wanted to do a little bit more with that. So you've got the bat. The problem I have with the bat is there's no animation in this game. What do bats have to do to stay aloft? They got to do this. That bugs the shit out of me. On title screens where you've got thunder and lightning going on, and then the bat's sitting there like this, I'm like, is this a freeze frame or is it not? So I wanted to have something, and bats aren't really that scary. I love bats. Maybe a vampire bat's a little scary because it sucks blood, but so I wanted something that could still fly, float, be fairly ubiquitous within the D&D universe. So I did a beholder instead. They kind of serve the same purpose. Ghost. Ghost is the stupidest monster. I mean, if it was like a ring wraith, that was coming at you and was a little scarier and kind of crossed the ethereal and the physical world, maybe. This looks like Casper with a weird head. I mean, again, good use of the graphics, but okay, so what can we have that has that jump scare? Remember I mentioned the lock boxes. Well, let's do it with chests. And let's do a mimic instead. That way you get the jump scare. And the cool thing about mimics and what I've done is that they behave like boxes from afar. But when you get right up next to them, you're like not thinking about, and you've got this thing ready to attack you. So that's kind of fun. Okay, so I wanted to do some gameplay updates. Remember I said that if I wanted to add cheat codes, I needed some more keys. I wanted to be able to test monsters and stuff like that. The enhancements weren't tracked, so let's take a look at what I have done to fix those. I needed to rewrite the hand controller and the key function scan to include all keys and all possibilities, including some chords that you use with the hand controller so you can get even more commands. I wanted to create icons for armor, helmet, and ring, because once you use them in the game, you forget what you have and you forget the level and you forget that they're even there, and they do affect how you play and who you attack. I mentioned the light ceiling and the light floor. I wanted to darken the palette, and I wanted to create a function that would actually wipe the map clean, at least of walls, so I could move around and see monsters further from afar and see how they render. So let's focus on these. So with an armor, helmet, or ring, when you take it, in the original game, it's gone. Did I use it? Did I not? I don't know. So I have added some little light gray icons up there. So when you pick up a helmet, a ring, or a piece of armor, it does disappear, but it now shows up at the top at the level that it is. You can at least have an indication of what you are working on. So that's up there. I also added a Q key. So what it does is, I've already hit the Q key in this particular screenshot, but it increases the physical health, the magic health, the spiritual health. It adds all you need in terms of 99 arrows, 99 health, 99 food. So I do that up there. Then I had a T key that allows you to teleport to the exit, so you can practice levels quicker without having to trudge back to wherever it was and remember where it was. And then again, I made it a deep dark dungeon. I have a dark sky, a dark ground, and I use what the guys who developed Doom said, and you darken the palette as you go back. You muddy it up so it has that perception of depth. I do that based on color here. And again, the D key wipes all the walls, and then you can see everything there. Now we have that map item. Maps come in 3 values. The lowest value lets you see all the walls, which are in green, and it shows where you are. The next best one will show where the ladder is. Okay, that's kind of nice, I guess. And then the most expensive one will show where the monsters are, and those are all the yellow things. Well, I don't really dig that. I would like to improve the map function. So first of all, the walls look like blue, the way they're represented in the visual viewport. Turn the monsters to red, but I'd like to have an additional item. You still show where the player is, you still show where the ladder is, but I'd like to also have the highest level show items so you can make sure you pick up and try everything. So there's those. Again, some future updates. Here are some of the things that I'd like to add. But the big question is, can I do all of this stuff in 16K? I don't know. Maybe I can. We'll give it a try. We'll add as much as we can. So what might the user interface for this look like? Well, here's a thing that I mocked up. It's still got the same feel. One thing is I thicken the walls. There's actually weight to this game now. A wall looks like a wall. It's not this weird, is this cardboard? You know. I moved the pack, which is your inventory, down here closer to the right hand, which is what you do all of the stuff from. It's your action key. You have to hold the shield on the left, which is stupid. I also moved the hands from over here to actually in the viewport. 2 things. The animation is quicker and easier, and there's 4x4 squares in the bottom I don't have to render anymore. I don't have to render the bottom of these front doors, which saves a little bit of time. And then that makes sense. When you pick up something, it's just going right here, and then you can put it in your pack. I also added some potential things. Maybe this is the direction to the ladder. I incorporated the compass here, so instead of saying east, north, west, south, you've got that here. This can identify monsters. Maybe this picks up items. They're also shown at the top. There are a couple of items that aren't used, treasures like a chalice and an amulet. Maybe make them randomly activate these charms within this thing. Here's the food, here's the arrow count. Again, it'll be visual rather than invisible, because you have to use this weird annoying thing that actually goes to count all of the arrows and food. It's annoying. And why waste a command on that? So what else am I working on? I'd like to tear apart Utopia, some of the other games that are there. I'd like to see what the AI in Utopia is like. Tron doesn't look like a Tron game at all. Although, again, I know I'm treading in dangerous territory because it's a Disney product, but I'd like to play with that a little bit. Biorhythms, which is, it's dumb. It has a Y2K bug. You can't enter any dates beyond 99K. That's an easy fix. You make it more bytes. And there's some others, but not enough time in the day. So what am I telling to all of you? Well, write more software. If you aren't part of a community that develops this stuff, try that. Explore new development tools like I did. Take a look at Ghidra and give it a look. port another program for the platform that you love, whether it's a Z80 or a 6502 or whatever, and try and just go through the process, see if you can port it. Always work to improve the libraries or header files for your particular system. Publish, just put it out there. You know, there's a lot of people who give it a try if you want to. And users will give you feedback whether you want it or not. The Good Idea Fairy will visit them that day and promote the process of learning, you know, and experimenting. I think that's important. Cool. Here's some of the folks who helped me on the project. Matt Heffernan in Rochester was able to go to the Strong Museum and do some of the research for me. Frank and Curtis were the co-developers of the Aquarius Plus, as well as some of these other folks. Matt Pills developed Aquarius Draw. Christian Simpson, kudos to him and the other guys for finally wrestling control and bringing Commodore back. Good to them. Jan Beta, of course, for all of his work. Salam. Some folks who are no longer with me, but who inspired me on my journey. Here's my references. How you can get in touch with me if you want to. I'll be upstairs at one of the tables right inside the doors to the main booth. If you can, scan this, answer some questions about it. It'll help the VCF do better work and, you know, how did you like this presentation and that sort of stuff. But in the meantime, with what little time we have left, any questions? Any questions on that? I will be available for longer discussions after. I want to be courteous to Salam as he sets up on his next one. But thank you all for being kind and laughing at my jokes. It's really great. So.